Hey, welcome to lesson number 4. We're going to look at dividing radicals. The last couple lessons we were looking at what radicals were, and then after that we looked at adding and subtracting radicals, followed by multiplying radicals, and today we're going to be looking at dividing radicals. And so let's jump into it. So the first rule we have for dividing radicals is if we have the square root of a over b, that's equal to the square root of a divided by the square root of b. Another way of saying this is the square root of a divided by b. And then when we have something like this set up, there are a few restrictions, meaning that a has to be greater than or equal to 0, b has to be greater than 0, and both a and b have to be elements of real numbers. So if you ever see this sign, that just means elements of. Alright, sometimes you'll see elements of whole numbers, elements of real numbers, elements of rational numbers. We can also use the rule the following rule to divide radicals of the form m times square root of a divided by n times times square root of b. Now, to divide the radicals, the rules are kind of similar to when we were multiplying radicals. So when we're dividing radicals, first thing is you divide the numerical coefficients by the numerical coefficients. So an example would be in this situation right here, m and n would be my numerical coefficients. We'd also divide our radicands by our radicands, and so my a and b would be my radicands. Alright, so here are my numerical coefficients, and here are my radicands. The last thing we need to do is make sure we simplify into our mixed radical form if possible. So my final answer should be left in mixed radical form. Alright, so let's look at class example number 1. First thing I have is just entire radicals, which is kind of nice. So no coefficients I need to worry about here. And I have the square root of 30 divided by the square root of 6. Alright, so the way you would read this is square root of 30 divided by square root of 6, or square root of 30 over square root of 6. In this situation, all we need to do is divide our radicand by our radicand. Alright, so 30 divided by 6 is 5, and since they're under that radical sign, we're going to keep that radical sign, and we have the square root of 5. Next we have example B. This time I have my coefficients, my numerical coefficients. And so we have 8 times the cube root of 21 divided by 2 times the cube root of 3. And so I have to divide my coefficients first. So 8 divided by 2, we're going to be left with 4. Next, I have my radical sign, and 21 divided by 3, I'm left with 7. So notice how I went coefficients divided by coefficients and radicals or radicands divided by radicands. Same thing here. 15 divided by 10. I can simplify that. So in order to simplify that, I know that these are both divisible by 5. So I know that 5 goes into 15 3 times and goes into 10 twice. And so I'd be left with 3 over 2. Now, if I have square root of 48 divided by 6, there's a couple things I can do here. First thing I can do is I can simplify this quite a bit. So we could just go ahead and divide this right away, but remember, if we have mixed radicals, we want to simplify into mixed radical form wherever possible. And so it will be possible to do so here. 48, if I have, well, first of all, if I have the square root of 48 divided by square root of 6, that's just going to be square root of 8. I'm going to be left with 3 times the square root of 8 divided by 2. Now, once I'm left here, I can simplify even further. So this is where we're going to be simplifying the mix into mixed radical form if possible. Square root of 8 can be also referred to as square root of 4 times 2 over 2, which would then give me 3 times that would break down to 2, or square root 4. And so I would be left with 3 times 2 square root 2 over 2. One thing I could do is I could just cancel out these 2's here, and my final answer would be 3 square root 2. Next we have an example where we have variables in my radicand, and that's no problem. In order to solve this, we're going to begin with our coefficients, divide by our coefficients. So 4 over 12 will break down to 1/3. And if I have a over b, what I'm going to be left with in this situation is, on top, those a's are going to cancel out. If I go coefficients, or sorry, my radicand, divide my radicand, I'm only going to be left with the root of b. And so there's a couple ways we can write this. We could write this as, well, 1 times the square root of b is just b over 3. Or we could also say this is 1/3 times square root of b. All right, both of these are acceptable ways to write this answer. All right, example number 2. Simplify the numerator and denominator and then divide. All right, so first of all, we want to simplify the numerator and the denominator. So in order to simplify, if we have square root of 54 and square root of 8, all we want to do is break this into a mixed radical. And so we won't worry about our coefficients yet. We'll just leave those there. So if I have 4 over 3, I'm going to leave them as 4 over 3 for now. Square root of 54 can be broken down into the square root of 9 times the square root of 6, and 8 is going to be square root of 4 times square root of 2. Both of these can be simplified. I'll have 4 square root of 9 is equal to 3 times square root of 6. 3 times square root of 4 is 2 times square root of 2. So I can simplify these even further. 3 and 3 will cancel out. 2 goes in that once, goes into this twice, and I'm going to be left with 2 times square root of 6 over square root of 2. But even this I can simplify if I follow my first rule, or my second rule, which was divide my radicands by my radicands. So my square root of 2 goes into my square root of 6 square root 3 times. So if I pretend there's a coefficient of 1 there, that's going to be 2 times the square root of 3. Alright, so you'd approach this question here the exact same way, where you got to first bring it into a mixed radical, and then afterwards you would simplify. All right, and so let's think about what goes into 126, and we're going to leave the coefficient for now. So 126, what smallest square root or perfect square will go into that? So let's try 16. So not quite, we got to go smaller. 126 divided by 9 is 14. That will work. So square root of 9 times the square root of 14. And 112, if we try 16 with that one, 7 times, that's going to be square root of 16 times square root of 7. Yeah, numbers over 100, I generally, if I'm guessing and checking, I usually guess and check around 16 first. Alright, so if I simplify this even further, I'm going to be left with 8 times, well, the square root of 9 is 3, square root of 14. I can't really simplify that any further. I could simplify it into 2 root 7, which I might want to do later on, but yeah, we'll see how it goes. But square root of 16, we would simplify that into 4 square root 7. From here I can simplify even further, or I can say, well, 4 goes in that once, and it goes into 8 2 times. So all I'm doing is I'm looking at my coefficients and seeing where I can find common multiples, where numbers will go into each other. But what I'm going to be left with is 2 times 3 root 14 over root 7. So 2 times 3 and root 7 over 14. So 2 times 3 is 6, and 7 goes into root 14, root 2 times. And so that is going to be my answer there, and I should have put an answer box around that as well. Let's look at this example here. So just like the other ones, I'm going to ignore the coefficients for now. That's just going to be, so I'll leave those as 10 over 20. Next, I want to find a way to break down this number here, so 162. So that's getting a little bit bigger. So let's see if 16 goes in that. Nope. So the next perfect square, or sorry, in this case, perfect cube. Yeah, I don't know why I tried 16. Perfect cube. So let's try 27. So that's going to be 6. So I know that root 27, cube root 27, times the cube root of 6 is equal to 162. And 128, well, let's go 128 divided by 8. Okay, so we can go even bigger, it goes even. Let's go to the next one, 64. Perfect. So cube root of 64 times the cube root of 2. Now I can simplify. I know that this will simplify into 1/2, but even before I simplify my coefficients, let's get these ones out of my radical sign. So let's leave those coefficients for now. It's 10 over 20. The cube root of 27 is equal to, put that in brackets, 3 times the cube root of 6. And my cube root of 64 is equal to 4 times the cube root of 2. 3 times 10 is 30 over 80. 4 times 20 is 80. Cube root of 6 over cube root of 2. So 30 over 80, we'd simplify that to 3/8. And I could have 3/8 times cube root of 3, because 2 goes into 6 3 times, or we could also say 3/8 times the cube root of 3. So remember, both of these are acceptable answers. They both mean the same thing. All right, next example. Divide each term in the numerator by the denominator and then simplify. All right, so divide each term in the numerator by the denominator and then simplify. So first of all, I have square root 6. That goes into square root of 24. Square root 4 times. 6 into 48, that would be the square root of 8. And square root of 108 divided by 6 is 18. All right, so remember, if we are adding and subtracting, we have to break this down into common radicands. And so square root of 4 is equal to 2. Square root of 8 is square root of 4 times the square root of 2 minus square root of 18, which is square root of 9 times the square root of 2. This is going to be 2 plus 2 root 2 minus 3 root 2. Now that we have similar radicands, we can simplify. And that's just going to be 2 minus, 2 is negative 1, so minus root 2. So it's coefficients minus coefficients if we are adding and subtracting. All right, now we're going to be working on something called rationalizing the denominator. Now, rationalizing the denominator occurs when we have a radical as our denominator, and we want to, if we're writing it in simplest form, we want to make sure that there's no irrational numbers for my denominator. And so square root of 13, for example, is irrational, and so in order to get rid of the square root of 13 on the bottom, we have to do what is known as eliminating the radical. And so we would do that by rationalizing it, so making it a rational number. So in order to do that, remember when we were multiplying radicals, if we multiplied a radical by itself, so in this example, I would multiply by the square root of 13. When I do that, that gets rid of my radical sign. Because if I have the square root of 13 times the square root of 13, that ends up becoming 13 squared, but that's in a radical sign, right? So this ends up becoming the square root of 169. Well, what happens when you square root 169? Well, same thing that happens when we go back to our original value that we actually squared in the first place. We just get 13. And so if I multiply a radicand by the exact same radicand, we end up canceling out the radical sign. So in this case, what I'm going to be left with is square root of 13 over 13. And that's all we would do. In this next example, we want to do the same thing, but instead of multiplying by square root of 13, we're going to multiply by the square root of 2 on the top and the bottom. Radicand times radicand would give me square root of 10 over 2. In this case, we're going to multiply by the square root of 6. Even though there's a negative sign, we're going to leave it negative. So I'm going to be left with the square root of 12. So 2 times 6 is square root of 12, and that's negative over 6. If I simplify this even further, remember this can be the square root of 4 times 3 over 6, in which case I would be left with 2, square root of 4 is 2, square root of 3 over 6. And then this would simplify even further. So 2 goes to that once, goes into this 3 times, and I'm left with square root of 3. And remember, that was negative. My last one, we're doing the exact same thing. We're rationalizing my denominator, so I'm multiplying those by square root of 3. That's going to become the square root of 60 over 3. Well, square root of 60 we can definitely break down even further. Make that a mixed radical. Square root of 4 and 15 over 3 is going to become 2 square root of 15 over 3. Alright, the last few examples, all we need to do is rationalize our denominator. So the exact same thing I did here, I'm going to do down here. Yeah, it's exactly the same thing that we're doing. I guess the only difference really is this one here, in which case when we rationalize our denominator, we only really need to rationalize the radical, right? So this is the only thing we want to rationalize. And so if I multiply these by root 7 on the top and bottom, I'm going to be left with 7 root 7 over 3 times 7. This is going to become 7 square root 7 over 21. 7 goes in that once and goes this 3 times, so we're going to be left with root 7 over 3, or 1/3 root 7, however you want to write it out. Yeah, and these other ones are exactly the same. So I guess the only, another one that might be a little different just because the notation is a little different. Square root of 18 over 5. Remember, we can rewrite this one as the square root of 18 over the square root of 5. So this and this is the same statement. If we end up with this, to rationalize, we end up multiplying only by square root of 5. And then if we complete this, we're going to end up with 18 times 5 is 90. So we're going to end up with square root of 90 over 5. Well, 90 is square root of 9 over square root of 10 over 5, or 3/5 the square root of 10. And this one, I'll leave for you to do. But let me double check your notes, see if that you attempted this one here. So lesson number 4, example 5C. And last one, So this one's not particularly difficult. We're just given two different commands, so to speak. First, simplify the radical expression by first rationalizing the denominator and then dividing the numerator and the denominator by square root of 2. So let's try that first one. I'm left with 3 times the square root of 18 minus the square root of 12 divided by square root of 2. So the first thing I want to do is rationalize the denominator. So square root 2 over square root 2. So remember, radicands times radicands. And so if you think about this being in brackets, then this 2 is going to be distributed to both of these numbers. So we're going to have this 3 times square root of 36 minus the square root of 24 over 2. So from here we can simplify this even further. Square root of 36 is 6, so 3 times 6 minus 24. Well, square root of 4 times square root of 6 is 24. If we simplify, over 2. So I end up with 18 minus 4 is, well, square root of 4 is 2 times square root of 6 divided by 2. Coefficients divided by coefficients. 2 goes into 18 9 times. So that becomes 9 minus, 2 goes into 2 once, goes into 18 twice, and goes into 2 once. So we're left with 9 minus the square root of 6. And a second way to do this is to divide the numerator and the denominator by 2, by square root of 2. And so if I do that, divide both by the square root of 2. And so essentially all we're doing is simplifying that statement. So radicands by radicands, right? So I'm going to be left with 3 square root of 9 minus square root of 6. Well, 3 times square root of 9 is 3 times 3 minus square root of 6, or 9 minus square root of 6. So this ended up being a little faster, but you get to the same answer in the end.